Hello and welcome back to Geometry, where you're going to prove algebraic equations all night with Bruce Springsteen, right? Springsteen, yeah, that's his name. And today we are going to learn about algebraic proofs. So the objective is I can use the properties of equality and congruence to justify algebraic proofs. Now remember, we've talked about equality and congruence before, and so we're equality is when two quantities are equal to each other, and congruence are when two things, two figures, two angles, two segments are the same, are have the same qualities to them. So proof. Proof is an argument that uses logic, definitions, properties, and previously proven statements to show that the conclusion is true. Note that proofs use logic, definitions, properties, all of which are part of deductive reasoning. So when we are proving something, we are using deductive reasoning. So that means we have general rules and we are applying it to the specific argument that we are trying to prove. This is the ultimate use of deductive reasoning. Proofs. Here we go. So there are three aspects of proof. First, you start with a given fact. Something needs to be given to you so that you have a place to start. Then, proofs are logical and organized. No matter if it's a paragraph proof, a two-column proof, or a flowchart proof, no matter how you prove it, it needs to be logical and it needs to be organized. And lastly, every step of the proof is justified and has a reason. And this reason is based off of a general rule, property, or prior theorem. So here are the properties of equality. There's addition, subtraction, multiplication, and division, properties of equality. Reflexive, symmetric, transitive, and substitution. So let's break it down and take a look at them one by one. So the addition property of equality is if A equals B, then A plus C equals B plus C. So this basically means that you can add the same thing, C, to both sides of the equation. The subtraction property of equality means that you can subtract on both sides of the equation. So if A equals B, then A minus C equals B minus C. The multiplication and division properties of equality show that you can multiply the same thing on both sides of the equation or divide on both sides of the equation, as long as the thing that you divide is not zero. Something over zero is indeterminate. It's impossible to find. Now, the reflexive property of equality is kind of hard to grasp because it's like an duh, and A equals A. So it's basically saying that something equals itself. When you see yourself in the mirror, your reflection and you are the same thing. Now, the symmetric property of equality are when two different things, like if A equals B, then you can write it in the other order, B equals A. So let's say I had a twin that looks the same as me. I'm forgetting what that is called right now. But if I had one of those twins, then we would be equal either way that it goes. So if I had two markers, this pen is equal to this pen, but this pen is also equal to this pen. Whereas the reflexive property is that this pen is equal to this same pen. The transitive property is similar to the law of syllogism. It's basically transferring over equal signs. So if A equals B and B equals C, then A equals C. So you can like skip over to there. So if like 2 equals 1 plus 1, and 1 plus 1 equals 2 over 2 equals 4 over 2, then 2 equals 4 over 2. And lastly, the substitution property of equality. And we've basically been using all of these all along, but now we're putting a name to it. So if A equals B, then B can be substituted for A in any expression. So if you have two things that equal each other, you can switch them out, substitute them out wherever needed. So these are the properties of equality, where we have equal signs. So let's solve an equation and write a justification for each step. So we are given the equation 4m minus 8 equals negative 12, and now we need to write a justification for each step. So first, the statement is what was given to us, and the reason is it's a given equation. From there, we can add 8 to both sides, and when we add 8 to both sides of the equation, we're using the addition property of equality. So after we add 8 to both sides, we can simplify by having 4m equals negative 4. 4m equals negative 4. And then what would we do next? We would divide by 4 on both sides. And dividing by 4 on both sides would be the division property of equality. And then lastly, we're going to simplify, and we get that m equals negative 1. So we've shown each step of the process. We've shown how we got there. So the difference now is that we're giving reasons for each of these, using the properties of equality. Now, let's take a one that we are solving an equation in geometry. So solve for x and write a justification for each step. So to solve for x, we're going to have to use the segment addition postulate. So nm plus mo equals no. That is the segment addition postulate. So since we have learned the segment addition postulate, that is one of the givens, given that we were given this picture. So from here, we can use substitution to substitute no equals 4x minus 4, nm equals 2x, and mo equals 3x minus 9. So we substituted in the lengths of each of these segments, and we've put in their expressions. So from here, we can simplify, and we combined like terms. You can say simplify or combine like terms. And then now I'm going to subtract 4x on both sides, and that's the subtraction property of equality, because I subtracted 4x, boom, boom, and subtracted 4x, and then simplified. So I kind of just put it all into one step. And then from here, I'm going to add 9 to both sides. So that was using the addition property of equality. And then I have 5 equals x. I can actually go one step further and say that x equals 5. And this would be using the symmetric property. Symmetric. Sorry, writing on this is still not the easiest thing in the world. Symmetric prop of equality. So I can shorten equality by saying equal sign. So remember, I know that 5 equals x. I can also write this as x equals 5, and that's the symmetric property of equality. The equal sign is kind of like the line of symmetry between 5 and x, or x and 5. Now, there are 3 properties of congruence similar to 3 of the properties of equality: reflexive, symmetric, and transitive. So the reflexive property of congruence is basically a figure can be congruent to itself. So figure A is congruent to figure A. And we can shorthand it as reflex prop of congruence. And so an example of this is segment EF is congruent to segment EF. It's congruent to itself. So that's saying the reflexive property of equality. This pen is congruent to this pen. This pen is congruent to this pen. Symmetric property of equality is if figure A is congruent to figure B, then figure B is congruent to figure A. This is that symmetric prop of congruence. So if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. Symmetric. The congruence is like the line of symmetry here, whereas here it's the reflection. Same. There's one figure involved with reflexive, two figures involved with symmetric. And then lastly, the transitive property of congruence is if figure A is congruent to figure B, and figure B is congruent to figure C, then figure A and figure C are congruent. This is the transitive property of congruence. So if segment PQ is congruent to segment RS, and segment RS is congruent to segment TU, then segment PQ is congruent to segment TU. Boom to boom. So now let's identify some properties of equality and congruence. Identify the properties that justify each statement. Angle QRS is congruent to angle QRS. This is the reflexive property of congruence because we're looking at the same figure twice. But it's not equality because there's a congruence sign. Now the measure of angle 1 equals the measure of angle 2, so the measure of angle 2 equals the measure of angle 1. This is the symmetric property of equality because we have two different figures and the equal sign here is like the line of symmetry between the two different measures. Segment AB is congruent to segment CD, and segment CD is congruent to segment EF, so segment AB is congruent to segment EF. This is the transitive property of congruence. It's transitive because it's kind of like the law of syllogism. There's like a logic chain going on, and it's congruence because there's a congruence sign. And lastly, 32 degrees is equal to 32 degrees. This is the reflexive property of equality. It's the same number, and we're using an equal sign. So with that, now you can prove algebraic equations all night long, and you can show that you can do it by taking the online quiz. Have a good one.